Examples on divisibility theory in the integers. Example number 1, show that root 3 is not a rational number. A rational number. Now prove by using contradiction. That is, we assume here, suppose root 3 is a rational number. A rational number. Then this root 3 can be written as, this implies this square root 3 can be written as, can be expressed in the form of m by n, and we assume this with the GCD of mn is equal to 1. That is, here it is irreducible fraction. That is, we know that here 1 by 2 is same as 10 by 20, which is same as 50 by 100, but here this is a reducible fraction and this is an irreducible fraction. So we assume here GCD of mn is equal to 1, that is, it is irreducible fraction. Now this can be written as m is equal to square root 3 into n, that is, we cross multiplication, so this implies m square is equal to 3n square. This implies this m square is multiple of 3, so this implies 3 divides m square, but this implies 3 divides m into m. By using Euclid's lemma, we know that as p is a prime and p divides ab, then either p divide a or p divide b. This, from this we can say that 3 divides m. 3 divides m. Say this is equation, or from this we can write m is equal to 3 k1 square. 3 k1 for some k1, for some integer k1. Say this is equation number 1. M is equal to 3 k1. If you square on both sides, we get m square is equal to 9 k1 square. If we put this value here in this equation, if we substitute the value, say this is equation number star, and if we substitute the value, put m square equal to 9 k1 square in star, we get 9 k1 square is equal to 3 times n square. If we divide 3 on both sides, we get n square, that is 3 k1 square is equal to n square. That is, this implies n square is equal to 3 k1 square. Okay, and this implies this n square is multiple of 3, so we can, from this we can write 3 divides n square. This implies 3 divides n into n. Again, 3 is a prime. From this, by using Euclid's lemma, we can write 3 divides n, and from this we can write n is equal to 3k2 for some integer k2. Say this is equation number 2. Now from equation 1 and 2, what is equation number 1? 1 is m is equal to 3k1 and n is equal to what? 3k2. From this, now since from 1 and 2, that is m is equal to 3k1 and n is equal to 3k2, from this we can we get GCD of mn will be or should be greater than or equal to 1, and which is contradiction that GCD of mn is equal to what? Mn is equal to 1. We assume here GCD is what? It is irreducible fraction here, but we got here GCD of mn is greater than 1 because there exists common factor for 3 for m and n, which is greater than 1, and therefore GCD is greater than 1, which is contradiction. Why it is contradiction? Because we assume here root 3 is rational number. From this we can write root 3 is not a rational number. Example number 2. Example number 2. Find a positive integer AB. Find positive integers A and B satisfying the equation GCD of AB is equal to 1, GCD of AB is equal to 10, and LCM of AB is equal to 100. AB is equal to 100. Simultaneously find all solution. Simultaneously find all solution. Okay, so given GCD of AB is equal to 10 and LCM of AB is equal to 100, and we want to determine a pair AB satisfying this condition. Now as we know that GCD of AB is equal to 10, this implies A is equal to, we can express, that is 10 divides A and 10 divides B. From this we can write A is equal to 10m and B is equal to 10n with GCD of Mn is equal to 1. Now, and as we know that the LCM of AB into GCD of AB is equal to A into B. So from this we can write the LCM of AB is equal to A into B is what? 10m into 10n divided by GCD of AB. What is GCD of AB? 10. So 110 will get cancelled here and it is equal to 10 m into n. So LCM of AB is equal to 10 mn. But what is LCM of AB? The given LCM of AB is equal to 100. You can see here the LCM of AB is what? 100. So if we put here LCM of AB is equal to 100, so it is 100 is equal to 10 mn. So if you divide 10 on both sides, we get m into n is equal to 10. So if you factorize this 10, we get 10 is equal to 2 into 5. Prime, if you obtain the prime factorization of 2 and 10, then we get 10 is equal to 2 into 5, and therefore this implies mn is equal to, or I am writing here, mn is equal to 2 into 5, and therefore this implies, and again we know that we want to select m and n such that GCD of m into n is equal to 1. Okay, so here we select m is equal to 2 and n is equal to 5, and what is the value of A? A is equal to 10m. You can see here A is 10m, B is 10n, and therefore A is equal to 10m, so which is equal to 20, and B is equal to 10n, which is equal to 50, and therefore the A is equal to 20 and B is equal to 50 is the solution for this condition. As we know that the GCD of AB is equal to 10 and their LCM is what? LCM is 100. Their LCM is 100. So this is the solution for the satisfying given condition. Example number 3. Find all values of x and y. Find all values of x and y which satisfy 243x plus 198y is equal to 9. Again we are going to apply here GCD theorem. We consider here A is equal to 243 and B is equal to 198. Now by using division algorithm we can write if we divide 243 by 198, we get quotient is 1 and remainder is equal to 45. Next, if we divide 198, if we divide this 198 by 45, then if we apply the successive, again we apply the division algorithm for 198 and 45, we get the quotient is 4 and remainder is equal to 18. Again, if we divide this 45 by 18, we get 18 into 2 plus 9, and if we divide 18 by 9 again, we get quotient is 2 and remainder is 0. At this step is remainder is 0, so the last non-zero remainder is 9. So this is the GCD. This is what the GCD of 243, and 198 is equal to 9. Now step number 2, now I want to express this GCD as a linear combination of 9. For that we are going to put the successive remainder here. So from this equation, say this equation number 1, say this is 2, and say this is 3. From 3 we can write 9 is equal to 45 minus 18 into 2. From 2 we can what is the value of 18? It is 198 minus 9 is equal to, the value of 45 is 198 minus 45, what is the value of 18? We want to put the 18, not 45. So the value of 9 is equal to 45 minus the value of 18 is equal to 198 minus 45 into 4 into 2, by using equation number 2, 198 minus 45 into 4. So if we simplify this, 9 is equal to this 45 1 times and this 45 8 times. So this is what 45 total 9 times, okay, and minus 198 2 times. Now the last we want to substitute the value of 45. So what is 45? 243 minus 198 into 1. 243 minus 198 into 1 into this 9 minus 198 into 2. So here 9 is equal to 243 into 9 minus this 198 9 times and this is 2 times. So this is 198 11 times. So this we can write this equation as 243 into 9 plus 198 into minus 11. We write this minus sign into minus 11 into 9. So if you compare this equation as 243x plus 198y is equal to 9, we get the solution of x is equal to 9 and y is equal to minus 11. This is the solution for the given equation. Next, show that example number 5. First we are going to take a 5 and then 4. Show that 1 plus 1 by 4 plus 1 by 9 plus dot 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 1 by n square is less than 2 minus 1 by n for all integer n greater than 1, or all integer n greater than 1. Now since the given statement involving set of natural number, we are going to show this result by using mathematical induction, using first principle of mathematical induction. So step first. Now here n greater than 1 means the base step is what? Step 2, step 1, base step is n is equal to 2. For n is equal to, for n equal to 2, on the left hand side it is 1 plus 1 by 4, and on the right hand side it is 2 minus 1 by 2. So the left hand side is, the 1 by 4 is 0.25, and here it is 2 minus 0.5. So this is 1.25 and this is 1.5. As 1.25 is less than 1.5, from this we can say that the result is true for, that is LHS is less than RHS, and therefore result true for n is equal to 2. Step 2, we assume here, assume for n is equal to k. Assume that this result is true for n is equal to k. That is 1 plus 1 by 4 plus 1 by 9 plus 1 by k square is less than, that is 1 plus 1 by 4 plus 1 by 9 plus dot dot 1 by k square is less than 2 minus 1 by k. And step number 3, here we want to show that inductive step, that is we want to show here result is true for or show for n is equal to, show that result is true for n is equal to k plus 1. That is, we want to show that 1 plus 1 by 4 plus 1 by 9 plus dot 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 1 by k square plus 1 divided by k plus 1 bracket square less than 2 minus 1 by k plus 1. So now consider LHS, left hand side. So it is 1 plus 1 by 4 plus 1 by 9 plus 1 by k square plus 1 divided by k plus 1 bracket square. Now the value of this bracket is equal to, by using step number 2, what is the value? It is less than 2 minus 1 by k. So this is less than 2 minus 1 by k plus 1 divided by k plus 1 bracket square. Now from these two terms, if we take the minus sign outside, this is 2 minus inside the bracket 1 by k plus 1 divided by k plus 1 bracket square. Sorry, not plus, it is minus. So since we take the minus sign outside, now this is what it is, less than 2 minus, we know that this is if we take the LCM here, it is k plus 1 bracket square minus k less than k into k plus 1 bracket square. Now this is less than which is same as 2 minus, what is k plus 1 bracket square? It is k square plus 2k plus 1 minus k divided by k into k plus 1 bracket square. Now this 1k will get cancelled here, so this is 2 minus k square plus 2k, 2k not k, 2k, it is only k, 2k minus k is k only, plus 1 divided by k into k plus 1 bracket square. As we know that say x plus 1 is less than x. So by using this we can write this k plus 1, okay, is sorry, not x plus 1, contrary. As we know that, say here what is say here 2 minus k plus 1 and 2 minus k. So what is this is 2 minus k plus 1 is less than 2 minus k. By using this technique we can write this as it is less than 2 minus k square plus k, okay, divided by k into k square, k plus 1 bracket square. We write this k plus k square plus k plus 1, which is less than k square plus k, since it is a minus sign here, you can, because of minus sign. So this is what it is less than. You can check here what is here 2 minus, say here 3 plus 1 and 2 minus 3. Okay, so 2 minus 3 plus 1 is what? Minus 2, and 2 minus 3 is what? Minus 1. So minus 2 is less than minus 1. So by using this technique we can write this k square plus k plus 1 is less than k square plus k. So if we take k outside, it is inside the bracket k plus 1 divided by k into k plus 1 bracket square. So this k will get cancelled here, 1 k plus 1 get cancelled here, and is less than 2 minus 1 divided by k plus 1, and that is what we want to show here, and this is what our right hand side. So we show that here LHS is less than RHS. So it is what? 1 plus 1 by 4 plus 1 by 9 plus 1 by k square plus 1 upon k plus 1 square is less than 2 minus 1 upon k plus 1, and therefore result is true for, result true for n is equal to k plus 1, and therefore by using first principle of mathematical induction and by using above 3 steps, we can say that result true for every n greater than 1. Now last example, example number 4. Find the greatest common divisor of number a and b. Find GCD of a and b, and find integer x and y, and also find x integers x and y such that GCD is equal to, that is this GCD of AB is equal to AX plus BY, for A is equal to 7469 and B is equal to 2464. So now we are going to apply here Euclidean algorithm to find the GCD of these two numbers. Say here, if we divide this 7469 by 2464, then the quotient and remainder we want to determine. Then here quotient is 3 and remainder is equal to 77. Next, if we divide 2464 by 77, then the quotient is equal to 32 and remainder is equal to what? 0. So here remainder is 0, implies the last non-zero remainder is 77. So GCD of 7469 and 2464 is equal to 77. Now want to express the GCD as AX into BY. So from this equation, say this equation number star, we can write 77 as 7469 into 1 minus 2464 into 3. So from this we can write this 77 is equal to 7469 into 1 plus 2464 into minus 3. So here if you compare this equation with D is equal to AX plus BY, then here A is equal to 1 and B is equal to minus 3. So this is the value of the value of A naught, X is equal to 1. If you compare this equation as D is equal to AX plus BY, then we get X is equal to 1 and Y is equal to what? Minus 3. Y is equal to minus 3.